please help me welcome our next speaker, Segun Adelowo, who is a lead machine learning engineer at Interswitch Group. Segun has years of experience in system design, application development, data science, machine learning engineering, and building payment and data products. During his talk, Segun is going to show how to maintain simplicity in keeping data fresh, accurate, and reliable. After Segun's talk, we're going to take a 20-minute break and be back at 3:30 Eastern, 12:30 Pacific to discuss data reliability from 3 perspectives in a live panel. You'll also have the chance to ask the speakers any questions, so make sure to tune in and get your questions ready. Looking forward to seeing you all there, but first, I'm excited to welcome Segun. Over to you.
Hello, good afternoon, good morning, good evening to everyone. Thanks for coming to this event. I'd like to appreciate the organizers of Data Reliability Engineering 2022 for having me here. It's an awesome privilege and I'm grateful. I'll be speaking about maintain simplicity in keeping data fresh, accurate, and reliable. Before I go too far, about me. I'm a tech enthusiast, both software and hardware. I love playing games. Gears of War is my thing. Mortal Kombat is my thing. And if you think you're up for it, we could take it outside and go on a few rounds. But apart from that, I work with Interswitch. Yes, I've been working with Interswitch for the past 10 years now, over 10 years now. And I've worked on platforms like the Quick Teller platform, which is the e-commerce platform, which enables bill payments and e-commerce financial services. I've also worked on a couple of machine learning projects. For example, a customer segmentation project, which was aimed at helping the business appropriate marketing efforts, marketing resources effectively to campaign so the necessary budget do not go well spent, for one of better words. Yeah. And I also worked on a machine learning platform. Here I built a machine learning platform that enabled the operationalization of ML models designed and serve them to systems so that the business can get the best use of them after the hard work that the various engineers have put in place for the good of the business. Not too much really from my hand. While at Interswitch, I've worked as a software engineer, a customer support person. I've also worked as a data professional in various roles. For example, I've worked as a data engineer, a data scientist, and a machine learning engineer. I've pretty much done a few projects here and there around the company. About Interswitch, Interswitch has a staff strength of over 800 plus, about 8,000 billers on the platform, about 26,000 agents on the e-commerce platform. These agents are a direct support to the government's initiative of enabling financial inclusion to the unbanked in the country, which has really gone a long way in bringing people to available banking services. Active business on the platform, there are about over 190,000 businesses on the Interswitch platform. Cards issued, because Interswitch is a payment company, card issued on the platform already. There are about 22 million cards issued so far. The company has a market evaluation of about $1 billion as we speak. As you can imagine, with this, all these stats, all these components that link to the company will result in the company having humongous amount of data over time. Now, I'd like to speak to the journey of the Interswitch journey, really. Yeah, so for Interswitch has been around since 2003, I beg your pardon, and still waxing strong to date. As of 2003, Interswitch had 0 transactions to start with, and this grew over the years. I'd like to speak on the point of view of being data-centric. The company has grown in terms of market presence, in terms of technology stack, in terms of business portfolios. But the focus right now with on that data-centric perspective, as that now the company has about hundreds of millions of transactions running into the systems monthly across the various channels and across the various devices we have. So this growth really, I would say, comes to all companies, depending on what your company strategy is. So if you're a startup between 1 to 2 years, you might not be experiencing this right now. If you're between 1 to 5 to 6 years, you might be close to this. If you're over 10 years, you might experience this as well. So I'm trying to say is this talk will pretty much cut across different areas in various businesses, meaning you could be a company here and you've experienced this already. You pretty much be confirming what you went through. If you're a business here and you are currently at this stage of growth and you're like, this is what I'm going through right now. And if you're a business and you're not at this stage, it's possibly a good pointer to you, more like a heads up to say, okay, this is what is to come in the nearest future, so be ready for it. I like to talk about the issues we encountered and issues you're likely to encounter as well as your growth surges and as you make advances in the market. For InterSwitch, we started out with just a few databases at first because we just had one or two applications solving business problems and customers were signing up on. This were from banks to corporates to individuals on the regular customers that sign up to use our product. This started with a few databases, and over time we had to add some more databases. Then additional, we had to involve additional ETL services. Then we had a data warehouse. This kept on increasing over the years. Subsequently, we had more databases, more ETL services, additional data warehouses, and right now we've just added a data lake to the mix as well. This pretty much goes a long way to show that data keeps growing over the years, and as your business grows, which I believe yours is growing as well, your business grows, you eventually encounter this level of growth. But the thing I'm trying to point out here, in spite of this growth, we need to be mindful because at this stage of surge, it's if things are not properly managed, it will lead to a lot of issues that will have a negative impact on the business and staff as well. Excuse me. So for us, the system that generated this data, we have e-commerce applications, transaction switching systems, CRM applications that act as data producers. Likewise, we have data consumers, more like the people, the entities, the internet that make use of this data generated by the other systems. Apart from the external data consumers, we have decision support systems, we have transaction settlement systems, we have arbitration, much where issues are being reconciled with between various parties, either beneficial with the bank, finance, customer support. It goes on along, it doesn't end there. But we do know that if these are not managed as expected, chaos is not far fetched. From what Gartner said every year, poor data quality costs organizations an average amount of $12 million. Apart from the immediate impact on revenue, we also have the long-term poor quality data, the long-term effect that poor quality data does to the business. The data ecosystem of that business pretty much goes in shambles. It would be a good thing to watch that and try as much as possible to prevent that from happening and save the money. We're pretty much go into some scenarios right now that just talks about what you might likely encounter or see as you grow in your various businesses, as you go in your journey, also in your data journey for your organization. The first scenario I like to talk about here, I call it the rise and fall of the dashboards, like the Star Wars salute. The rise and fall of the dashboards. Here, a short story here I have. A data engineer built a pipeline to feed matrix monitoring dashboards created by a data analyst, like we normally do have, using a few data sources and queries. And users were elated. Wow, this is nice, awesome. What happened next is typical. Why not add an additional data source? Why not add an additional? Why not add a new dashboard? Why not make it go like? Why not do this? Why requests keep coming because one, a problem is being solved, but the business wanted more. It's fine, but the issue is all this was fine until the number of users grew, additional data sets added, interwoven spaghetti code, as you would call it. All this resulted in a significant drop in processing time, which made the dashboards unreliable. We could say this could be a result of poor processing time and performance issues, which you typically experience from time to time. Another scenario we could also encounter is one about a junior engineer. I call him the bug slayer for want of context. So here, a junior engineer was assigned a task to investigate and fix an issue with a production pipeline, right? The engineer went on, rolled up the sleeves, and ran to the code. Ran to the code with the necessary production logs. Minutes later, he got stuck at a line with fancy smart transformation code. Not bad. That was not easy to understand. This delay created a backlog of unprocessed events with ripple effects, which involved processes that are indirectly dependent on what the engineer was working on. In essence, trying to fix the code took a lot of time because of lack of proper understanding and cascaded into other businesses that depend on that pipeline for their own day-to-day activities. Another scenario could paint a picture of a complex system. This example of a DAG, multiple systems interwoven, ideally, truth be told, trying to find a problem to fix in this kind of scenario will really be a very daunting task. We have systems like this are present in most businesses. If you do not cater to the needs of these growing businesses in time, you could end up with such scenarios as that. You do not want that. So a little about the impact, right? So when the issue happens, maybe in your data pipeline, your ETL services, something breaks, let's say in the data engineering office, so to speak, either with the data platform, warehouse, or data lake. So if it's still within the data engineering team, it's under control from what we see in this little chart here. But time is pretty much not on our side here. The sooner these things are fixed, the better. Because if it's not, it cascades. The next team that gets the brunt of this is the data analytics team or data science team. Why? They feed off the data pipelines created to do their insights for their BI, for models being developed. It can be frustrating to know that corrupt data is coming to the system. They are waiting endlessly to get these things fixed. They have customers buzzing them. When will this be ready? When will this be sorted? These are challenges that these data science teams will face because of this corrupt pipeline due to an error that's not been fixed. This cascades also into the customer-facing application like recommendation engines. So these are customer-facing systems that depend on the output of the data science team or data analytics team. This also goes ahead into affecting decision systems in the company, whereby employees use the decision system for their internal processes and they are unable to guarantee the result of their query or their report because of these issues that are still prevailing. It goes on and on and on till there might be public outcry, litigations, suits flying up and down the air. It is not a pleasant place to be for a company. So, another brief scenario I like to talk about here is about a product team. I call this the future that was not. Here, a product team was pumped, set to go live with their flagship product. Having done a lot of marketing campaigns, a team pushed the deploy button and they were live. Awesome. In the midst of the excitement as user activities grew, a data-driven feature starts to fail. Wow. On doing critical investigation, it was found that the needed data pipeline for the feature was not in production yet. The data team was not adequately carried along. Pretty much poor change management. It's very subtle, but it can really cause damage to a rollout process or the business or damage the business reputation as well. A brief scenario also, I call it ding dong. I call it ding dong goes the bell. A company A made aggressive growth plans and over commitments, which involved various feature additions, updates. This led to increased pressure on the engineering team, sadly. In a bid to meet targets, this engineering team took shortcuts during development to make sure the targets were met. Awesome. Months down the line, the growth came, but the application performance gradually declined, subsequently led to outages. These directly affected the company's public profile and revenue, typically unpaid technical debts. Yes, you had targets, you made the target, but you left a lot of things hanging in the back and never came back to it. And sadly enough, at this point, we have some engineers pretty much just exit the building, and that knowledge could be lost if not properly attended to or handled. In the light of this, we would say this chaos pretty much is made up of a few items that I've talked about so far briefly: poor processing time and performance, troubleshooting nightmares, poor change management, unpaid technical debt. It doesn't end there. A lot more is involved. But hope it's not lost. Regarding poor performance, poor processing time, what could be done could be as simple as implementing data pipelines to be simple. Different transformation and business logic can be written to run in parallel where possible, which speeds up execution time. It's not just about having all the business logic in one place. It's advisable to have your DAGs, your tags, your data pipelines follow the separation of concern principle. Let your tags do one thing, let your data pipeline do one thing. Give it focus. It's easier to support and maintain when your items, your components have such focus. Also, regarding the bugs, the troubleshooting nightmare, sorry. Data pipelines could be written with good coding standard. It makes it easy to isolate issues, rerun data pipelines effectively, like what's listed in, I read this article, this material, which I'll share shortly, in a summary of clean code by Robert C. Martin. Here, it talks about follow standard conventions. Leave the campground cleaner than you found it. Here, I like to talk about refactoring. Yes, you're working on a piece of code, you see an opportunity to improve the code, go ahead, by all means, improve it. It will add more good to the team and the company at the long run. Be consistent. If you do something a certain way, do all similar things the same way. Meaning, follow a particular pattern so that whoever comes after you or whoever is reading the code subsequently will have it easy to understand what is being done and can easily innovate around what was written, what was done, and people extend the use cases as well. Use descriptive and unambiguous names. More like express yourself in the code, explain yourself in the code. Use names that are easily understandable, not variables like A, B, C, X, Y, Z, 1, 2, 3. Explain, use names that relate to the problem, use names that relate to the function that which the store procedure, the function, the method is doing. Also, rigidity, talking about rigidity and fragility. Rigidity, here it's talking about the software is difficult to change, meaning a small change causes a cascade of subsequent changes. The next one says the software breaks in many places due to a single change. We should try to avoid this because, see, truth be told, which is easier to implement here? I have here two castles. One is a castle, a knitted castle, knitted from using thread. One is a Lego-based castle. If you want to make a change, which would be easier to make a change in? Definitely Lego-based castle. It's easier to make changes here, meaning codes, components should be modular by nature. You can move things around, and when business needs changes, when the business grows, it's easy to swap out various components and replace them without bringing down the house. This leads to easier. This makes easy to support the systems better. Um, Moving on briefly, looking at this picture now. This is the same four strand used in in six different ways. You either choose to be figure one, straight code, or it could be figure six. It advises to stay in one. Yes, code can be fancy, looking good, but it's not about being fancy, but it's about being usable, maintainable, and it can easily be supported. These codes make changes to the data in the pipeline, and this code needs to be written to the best way that people can easily understand and run with it. Okay, and for regarding technical debt, this is so crucial. Short or long-term business targets should be agreed upon by all stakeholders. This includes engineering. You cannot leave engineering out of the mix. Do not, as engineering, do not overcommit. As a business, do not overcommit to the board. Yes, there are instances where aggressive steps need to be taken as a business, but it's advisable to also scale up the team as well. If the target must be met, scale up the required teams that are meant to deliver on this target, scale them up with the necessary resources, manpower to make these targets come to pass. And also, you got technical depth. Be deliberate about technical depth. Yes, meeting this target led to the creation of technical depth. Make our plans to pay back this debt, to clean up this technical depth from time to time, and leave the code a lot cleaner. But should be told, there's no magic wand in all of this. You cannot bring a rabbit out of the hat or a dove out of the hat. Some work needs to be done. What's required to make this work? A checklist of items I believe could go a long way in helping this simplicity pan across all the various parts of our data ecosystem. We want to get management buy-in. It's the business is there for a win-win for the customer out there and for the staff of the company. Management buy-in, tender the case, let senior executive know what's needed to be done to better the code base, to better the data infrastructure, properly staffed and maintained and motivated team. We cannot overemphasize this. Yes, there's work to be done, but if the staff is not properly motivated, the desired output will not be seen. Technology stack. How obsolete is our technology? How obsolete is the processes you have? It's good to review this from time to time and make sure that we have the best, not necessarily the newest shiny thing, but what works for the business and what works for the company. It's important to have data dictionaries and service catalogs. It helps people to know where what is and how to navigate the data ecosystem within the organization and not having to call two, three, four people to understand what was written here or what this project is about. I agree with SLAs. This is important. Why? Because the data pipeline, the data teams, the data ecosystem is serving customers at the end of the day. These SLAs are to help give room for unexpected situations where the team is legitimately working on resolving them, but needs to manage the expectations of their customers. So SLAs will be good in managing expectations of customers, which will eventually turn out to then manage expectations of their own customers. Data governance team. I believe this is pretty much the heart of it. We can have all this infrastructure created, set up, configured, and tailored and customized and all that, but we need a data governance team to ensure these structures are still running in place. These checks are still being maintained, and these standards are still being followed. A data governance team is really important to ensure that the essential policies, standards, recommendations are being adhered to from time to time. It's easy for an individual to drop the ball, but one is able to track the system from day to day and ensure that no one is lagging behind. Lastly, education of data users. It's good to help data users to help the internet users know where the data is and how to best make use of it for the various business needs. So this doesn't end. It doesn't end here. It goes way beyond all I've said. But I know I've been able to resonate with one, two, three, four, a number of people about how to keep your data simple, keep your data effective, accurate, and maintainable by keeping things simple. In essence, do not over engineer your code, make it easy to understand, put necessary processes in place, do not unnecessarily for want of a better word, complicate matters in the essence of trying out the latest fancy tool in town. Keep things simple, and the data ecosystem will get the better part of it. I believe that's the end of my talk. Thank you.